Okay, today I'm going to explain about successive ionization energy. But first we have to know what is ionization energy. Ionization energy is defined as the amount of energy required to remove the most loosely bound electron from the gaseous atom. Okay, from the example, we can see when the first electron or the most loosely bound electron is removed, the amount of energy required is less than the energy required to remove the electron in the next successive shell. This ionization energy goes on increasing with the number of electrons removed. So we can see here, the third ionization energy is more than the second ionization energy, and the list goes on. So, the number of electrons removed from the successive number of shells and the energy involved is called successive ionization energy. Okay, in a cation, the attraction between the nucleus and the remaining outer electrons is stronger compared to that in an atom. This is due to the fact that the valence electrons are closer to the nucleus. So, the attractions between the nucleus and the valence electrons are stronger. Okay, for example, the successive ionization energy of beryllium in kilojoule per mole is shown here. So this is the first ionization energy, this is the second, the third, and the fourth ionization energy. So as we can see here, the third ionization energy is very much higher than the second ionization energy, which means that the second electron is removed from the valence orbital while the third electron is removed from the inner orbital. So from that we can conclude that successive ionization energy of an element can be used to predict its valence electronic configuration. Okay, for the valence electron configuration for transition elements, we cannot use the successive ionization energy. This is because the electrons are firstly removed from the 4s orbitals. So the second reason is because most elements have big difference between ionization energy 2 and ionization energy 3, which means that we cannot determine the valence orbital of the atom.
Okay, from the graph, we know that element Z have 13 electron valence. So first, we look at the first ionization energy. The first ionization energy is from the outer shell, and the last ionization energy is from the inner shell. So, n equals to 1. So we can see that this drastic change in electron ionization energy level to ionization energy curve. So we can got n equals to 2 in the middle, and there's another drastic change electron at here. So at the first ionization energy, n equals to 3. Okay, from this graph, we know that element Z have 3 valence shells. So we know that Z is from the group 13 and period 3. Like I said just now, the element Z is from the period 3 and the group 13. From the graph, it states that all electrons in element Z is removed. So we know that element Z has 30 electrons, which means element Z has 13 protons too. So element Z has 13 protons, and we can find the electronic configuration of element Z, which means 1s2, 2, 2s2, 2p6, 3s2, and 3p1. Okay, from the result, we know that element Z have 13 number of electrons, and element Z have 3 electron valence, and the electron will release in the positive charge.
When you got table question, first thing you must analyze the table by finding their difference. Okay. First, we must find the difference between element P, difference of ionization energy 2 minus ionization energy 1. It's equal to 4100. And then ionization energy 3 minus ionization energy 2, it's equal to 2300. And then proceed to ionization energy 4 minus ionization energy 3, it's equal to 2600. Then we proceed, we continue with the next element with the same step. Find the greatest value of the difference between ionization energy. So from this difference, we can determine the group of the elements. Like for example, this is group 1. Why it was in group 1? Because we can see here, the ionization 1 is always from outer shell. So the drastic increase in energy shows that the second electron is removed from the inner shell. This is for example of element T. Okay, we proceed to the question. Okay, the second ionization energy is the minimum energy required to remove an electron in its ground state from A+1 charged ion in gaseous state. For example, we use beryllium. Beryllium has 4 electrons. So when the first electron from outer shell is removed, it is called first ionization energy, which is 1+. So when the second electron is removed, it is second ionization energy, which required more energy, and it is 2+. From the table, we can deduce the group of element R by finding the difference of ionization energy of element R. So you can see here there is a drastic increase in ionization energy from ionization energy 4 minus ionization energy 3. More energy is required to remove the 4th electron. Thus, the 4th electron is removed from inner shell, meaning that R have 3 electron valence. So here we can find the answer that R is from group 13. Okay, from the table, we can find the element that has the oxidation number +2. So it was S element and Q element. It was based on the difference of its ionization energy, and from the difference of ionization energy, we can find the group of the element. We can determine that S and Q is from group 2, which carries +2 ions. From the table, we can find out that Q and S is from the same group. Their first ionization energy is because Q has smaller ionization energy than S. Q is located lower than S in the same group. The size of Q is bigger than S because Q has additional shell compared to S. Thus, the shielding effect in Q is greater. The valence electron is farther than the nucleus, so the attraction between electron with the nucleus is weaker. Less energy is required to remove first electron from Q.